Hello, my name is Roland, and in this video I want to show you how to create a simple macro using Python 3.9. This macro will create for us the projection plane for a view or multiple views selected. The plane will be created in the linked document part. Okay, so basically we will select our view, we will click the, the macro from the toolbar, and then we have done the message done. We will go to the part, and we will see in our part we have the export projection plane. Geometrical set with all the features inside. We have the origin in the absolute axis system and two lines, basically the x and y of the view, and between that two lines we have our plane. We see this one is not a normal part. We don't have any planar faces, so yeah, it's quite hard to reach the projection plane. I don't know the command from the drawing, if it's some command in drawing to reach for this information. That's why we have a macro. Also, we can select multiple views, and the same, we will go to the part. We will see in the last geometrical set, it's keep adding geometrical set. We have the front view and the auxiliary view. We will use the naming to keep track if we, I don't know, maybe we will select multiple views. Okay, I will use Python 3.9, and also for this you will need to install with pip. I will make a comment here. We will need to install PyWin32. This one it's a library that help us to get the CATIA objects. Okay, for this application I will use Sublime text editor. You can use any text editor you are used to. For me it's simple because yeah, I learn with this one and I will continue with this, but yeah, you can choose any one you want. So first we will create a new file with extension .py, and we will save this file in our project folder. For me it's already saved, so yeah, you need to do the same. Then we will import our libraries. This library is the win32 com.client. This one basically, like I said, it's from PyWin32 to be able to grab the CATIA objects. Then I will import from sys the exit, and now we can start. Okay, first we will get CATIA. Basically, CATIA is equal with win32 com.client.dispatch, and then we have CATIA application. Okay, now we can see if we will print, let's say, CATIA.activeDocument.name, active document, yeah, okay, document.name. If we will print CATIA active document.name, we will see here we have our active document drawing one, CAD drawing. So basically here we can say, okay, the active doc name. Basically we will need this variable to check each time we run the script, a drawing is open. So for this we know basically if, let's say, cat drawing, the extension of the file, if it's not in our variable here, then we have a message print not a drawing open, and then you can exit the application. This exit is imported from this one, from the sys. Okay, let's say I will go to CATIA and then add the active window, the part document, and then run. We will see not a drawing open because the extension is not inside our name, and then the exit appears and close the macro. Okay, we'll go back to the drawing. Okay, after we know we are in the correct document, now we basically reach for the selection. Like I said, we will select first the views, and after that we will manage that selection. So first, the variable for selection, I will create OCell equal with katia.activeDocument.selection. Okay, first to understand this, let's see the number of selection added in our selection. First, we can print, okay, how many selection we have. So in this situation, we see we don't have any selection. Only if we will select the front view, now we see we have one selection added. So we have our selection, and now we will need to check if we have something in the selection. First, I will use an if statement. So basically, if all selection.count bigger than 0, then we have something in the selection, and then we will need to loop to all the selection to manage each selection separately. So first, I will create an for I in range the same, so selection.count, and then we will create now here our variable for selection, and we have ocell.item I plus 1. So I use this I plus 1 because the 4 in the range will start from 0, and we need to start from 1 to the end of the selection count. So we have this one. Let's see what we have. We can print, we can create an f function, and let's see the name. It's equal with selection.value.name, and then we have the type. The type is equal with selection.type. If we will go and run this application, we see we have the drawing view and the drawing text, the front view name and the text one. Here again, we will need to have type doc. It's equal with the selection type, and if type doc it's equal with drawing view. Now we are able to manage our views, only the views, not the text if selected or something. Okay, what we will need to start, we will start to create a variable here for the view. The view basically is the same with this one, dot value. Okay, after this, let's see if we grab the first information that we need. It's the parent of the view. So we will need to see which is the link to the view and which is what is our part name to be able to build something there. So parent link it's equal with its view, and then we will need to add generative links first link. So generative links dot first link, and then dot parent. And maybe if we want to see the same, we will make a f function. So for the view, we have here view.name. We have the link parent link. And if we will check, okay, we have the parent link dot name. And now we see we have the test part, cut part. So I will add that name here to the end. because I will use this variable. Maybe we will check multiple views and we have multiple parents, so we can manage to have them in a list for parts. I will create maybe the part list. It's equal with this one. Okay, and after this we can add into our part list with the append our parent link. Okay, now we have the part, we know where to store our information. Now we will need to check our projection plane. So to check this one, first we will need to have some variables. Let's say first it's x1. I will define the type of the variable because I will need to pass to a function. So I need to have the same type of variable defined. So we have x1, y1 equals float, z1, and then x2, y2, and z2. And we have a typo here. Okay, so we have the variables. Basically, each value here, these are the vector directions for the first line, and here are the vector direction for the second line. And then we will have the x1, y1, z1, x2, y2, z2 equal with, and now we will get our information from this function. So we have the view dot generative behavior, get projection plane. Okay, we can easily print this value to see if we have the correct information. Okay, so now the information is correct. We have the values. The values are stored into these variables. But now we need somehow to get our values and add into a dictionary. So on the top, I will define a dictionary for the values. And let's see, data view maybe. It's equal with dictionary. And inside our dictionary, we will append our value. So data view, at the key will be the name of the view to be easy to grab, and then our value are all six values. Okay, so everything is correct. Now we loop to the selected views, and we will grab also the parent link and also the get projection. After this, we will need to go inside our cut part and then create a geometrical set, a point, and two lines and a plane. So we will create first the variable to grab the part. So this part is equal with CATIA.documents.item, and here we will need to put the name of the item with also the extension. We know our values are stored into a list. In this situation, I don't want to check the list, all the list. I will use only the first value. Let's see the list. We see in our selection, one moment, I have only one. I will select multiple selection, so we see is the same part. I know it's the same part. I don't want to check it. If you want to check it, you can check it here before you set the part. Okay, we have the variable for the part to the extension part because we are working now into a part. Let's create first geometrical set, then create the geometrical set. Okay, so first geometrical set will be a geoset equal with this part dot hybrid bodies dot add, and then we need to name it geoset dot name. We will name export plane from 2D. After we have this geometrical set, we will need to create a point because we need to create two lines. We will start from 0, 0, 0. Maybe will be easy to manage. I don't want to grab any point from the selection. I will need a variable for the hybrid shape factory. So we have this part dot hybrid shape factory, and after this we can create first point. So point main, it's equal with dot add new point coord, and let's create a point in 0, 0, 0. Okay, so now let's check if we have everything right. So we need to have the drawing, we have the selection. Okay, I need the parenthesis here and check again. Sorry, I need here not a parenthesis, it's a part. I need here to add the part. Okay, so it's finished. If we will go to our part, we will see basically we have the export plane, but we don't have the point. Okay, let's see, let's check the point. Why we don't have the point? So we don't have the point because we didn't append this point. So we create the point, but we will need to append. So we will add the geoset dot append hybrid shape. Append hybrid shape, and what we need to append, we will need to append the point main. Also point main dot name equal origin. Okay, let's run it again. Let's check. We will have our part. This one is not updated, so we will need also to update, and then we need to have this part dot update. Okay, so we have the geometrical set, the point, and it's updated. Now we need to create from that point two lines and a plane for each view selected. To do this, we will create again, we will start using a for. Now we will enter into the dictionary that we create for each information of the view. So for each item, for item and value, so item will be the key, the view name basically, and the value will be the list, will be the values for x1, I1, Z1, and so on. So what we have, we have the item value in data view dot items. Okay, so now we are in this for. Okay, so here basically we can create our first direction reference. direction reference, and we have direction by coordinate, and here can be add new direction by chord. Okay, and our values in the first direction, let's say, yeah, will be the values from here. So we know the 0, 1, 2, 3, 4, and 5. So for the first line, here we have the value 0, and then we have the value 1, and then we have the value 2. This is the first direction. Okay, let's create the second direction. Direction 2 will be 3, 4, and 5. Basically, our dictionary has a list inside, and we will grab each value from the list. Okay, we have the two directions, and now we will create the line. So first line, let's say we have, for the first one, we have the line point direction 1. Here it's equal with add new line point direction. Yeah, and in this function we need to add our reference. First reference, I need to add the point, the origin. Here let's create the point reference here, this part, create reference from object, and we will create a reference from this object. So okay, first will be the point, then we will need to add our direction. So in this situation we know we have the direction to this coordinate, and then start value, let's say 0.0, and then end value, and if it's mirror or not, I will take the false. Okay, so we have basically create the first line. This line name, let's define as item. This is for the first, let's say X. Okay, so we have the name, and we will now to append. We can directly copy this one to this, and then append the second, not the second, our line. So after this, we will need to create the second line. I just copy paste and change the names. So the line point direction 2, we have the reference, we have the direction by coordinates 2, and then we have the start of the line, the end of the line, and if it's mirror or not. So I think this is what is done. Okay, we have the name. Let's see, here will be Y, and then we will need to append the second. After this, we can update this. Okay, and now we have also the parts. Let's see if everything is okay. I will select the front view, go and run. Okay, let's see what is the error. So no, this is add new point line dir. We have add new line point dir. It's not the point direction, it's point dir. Okay, and run it again. Everything works okay. We go into our cut part, and now we see we have the line from the front view X, and for the Y we have the values from each input. We will delete this one, and now we need to go back and create our plane. Okay, create the plane. Okay, our plane basically it's made between these two lines. So we have the create plane, the plane lines, it's equal with add new plane to lines. And we have the input one, it's the line one, and the input two, I by mistake hit Control B. Control B for me it's running the program. And we have the line two, create plane dot name. We have here now, let's see, I think we will directly name item, and we will need to append to the geometrical set this line. Okay, so now we will run it again. We'll go inside the part to see what we have. Yeah, we ran too many times. Okay, we have the point, the line, and the plane. Okay, go back. I will select the both of the views, maybe select some text, and now run. Now we see basically we have for each view we have the origin, we have the lines with the name proper name according to each selected view. Okay, our application in Python it's done. Basically, what can we do? We can go and install also from pip the Auto-py-to-exe. You can search online to create an exe file from this, and also you can directly run from CATIA. How this one works? We can go open a command prompt, Auto-py-to-exe. Here I will select my path. Let's see, I will have this one. After this, I will go to the settings, browse here, let's say maybe exe file, okay, and just convert py to exe. We will wait a while, and then our exe file is done. We have here the exe file. I think I didn't select the one file, I select one directory, doesn't matter. Let's delete this one. I want only one file, I don't want to have the entire directory. In the same path and convert again. Okay, and now if we will run this, let's select these two. We will run this, and after it's done, we will see